You can sometimes identify a linear function by looking at a table or a list of ordered pairs. In a linear function, a constant change in x corresponds to a constant change in y. And so that's what we're going to be looking at in these next few examples. We're going to be given a list of ordered pairs in a table, and we're going to try to identify whether it's a linear function or not by looking at the constant change in x, and if that corresponds to a constant change in y, then what we know is that we have a linear function. All right, let's look at a few examples first. Now we're just going to kind of appreciate these examples because it's kind of all worked out for us, but I want you to kind of look at what is that constant change in x, all right? So we have our table here, right? There's a list of ordered pairs, -2, 7, that's 1, -1, 4, 0, 1, and so on. And if you look and we look at the change, well, how do you get from -2 to -1? Well, you add 1. How do you get from -1 to 0? You add 1. You go -1 plus 1, and that's how you get 0. How about from 0 to 1? Well, you add 1. 1 to 2, 1 plus 1 is 2. So we have a constant change in the x values here. What about the y values? What's happening from 7 to 4? Well, 7 take away 4, 7 take away 3 is 4. Okay, does that same thing work from 4 to 1? Yeah, 4 take away 3 is 1. 1 take away 3 is -2, and -2 take away -3 is -5. So in this table, we have a constant change of +1, right, for the x values, and that corresponds with a constant change of -3 for the y values. And if you see and you plot all those points right here in this lovely graph, you see that it is indeed a linear function, all right, because it has that constant change in x that corresponds with the constant change in y. So that's basically what we are going to be doing in the next couple example problems. Okay, let's go ahead and look at this next one. All right, again, we're appreciating this one. Let's see if it has a constant change in the x values. If you look from -2 to -1, it's increasing by 1, -1 to 0, increasing by 1, 0 to 1, increasing by 1, 1 to 2, increasing by 1. So that's great. We have that constant change in x, right? So that is wonderful. What about the y values? Do we have a constant change in the y values? Well, here from 6 to 3, 6 take away 3, that's how we get 3. So, okay, what about, does that same thing happen from 3 to 2? No, it doesn't. It's just 3 take away 1 is 2. So this has a change of 1 and not 3. So this isn't constant. This isn't the same. Constant means the same. What about from 2 to 3? Well, now we're adding 1, and then from 3 to 6, we're adding 3. So this does not have a constant change. So in this table, a constant change of +1 does not, and that's really, really important, it does not correspond to a constant change in y. We don't have that. We are just all over the place with y. And if you see when we graph this, it actually ends up being, you can tell it's not linear. This is actually a quadratic function. So it is a function, but it's not a linear function. So yeah, all right. Let's go ahead and look at the first example that we're going to work on together. So what we have is we have a list of ordered pairs. If you have something like that in your homework set, you want to take that and convert it into a table just by knowing this is your x value and your y value, x and y, x and y, and x and y, right? So we're just going to tell whether this is a linear function, so we got to look at those values. So what's happening between 0 and 4? Well, you add 4, right? 0 plus 4 is 4. What about from 4 to 8? Well, 4 plus 4 is 8. So far, so good. What about from 8 to 12? Well, you add 4. What about from 12 to 16? Well, you add 4 again. So this is great. So far, we have a constant change in the x values. What about the y values? What's happening from -3 to 0? Well, -3 plus 3 is 0. What about from 0 to 3? Well, 0 plus 3 is 3. So far, looking good. What about from 3 to 6? Well, 3 plus 3 is 6. And from 6 to 9, you add 3 again. So this is great. We have a linear function because a constant change of plus 4 in x corresponds with a constant change of, how much is that y? Plus 3 in y. All right, that's it. Okay, let's go ahead and look at a different example. Example 2b. So again, we have an ordered list of pairs, and we're just going to put those into a table and then look at their relationship and see if there's a constant change in x and a constant change in y. All right, so what's happening from -4 to -2? Well, -4 plus 2 is 2. What about from -2 to 0? -2 plus 2 is 0. From 0 to 2 plus 2. 2 plus 2 is 4. So far we have a constant change in x. That's awesome. What about from y? 13, how do we get from 13 to 1? Well, we would subtract 12, right? What about from 1 to -3? Well, we would subtract -4, so 1 minus 4 would be -3. What about from -3 to 1? That would be adding 4. So this is definitely not a constant change in y. And then from 1 to 13, it would be plus 12. So we would say not a linear function. Because a constant change of plus 2 in x does not correspond with a constant change in y. All right, so now it is your turn, ladies and gentlemen, to check it out. I want you to try this problem here. Go ahead and work it out. Here's my friend the Pause Dragon, reminding you to pause your device, work out this problem. When you get done, press play and we'll talk about it and go over it together. All right, see you in a bit. Okay, let's see how you did. So we're gonna tell whether this set of ordered pairs is a linear function. So we're going to look here from 3 to 5. We add 2, add 2, add 2, and from 9 to 11, you'd add 2. What about here? What's happening? Okay, 5 to 4, minus 1, minus 1, minus 1, minus 1. Perfect. Constant change in x, constant change in y. So yes, this is a linear function because a constant change of plus 2 in x corresponds with a constant change of -1 in y. So if you got that one right, yokorikimashita. You did a wonderful job, and I'll see you in a little bit for example 3.